Okay, it's about 7:10, depending on which of the 5 or 6 clocks I look at here in the room, but we're going to go ahead and start. I'd like to welcome everybody to the September 2021 Atlanta Radio Club meeting, monthly meeting. Welcome. We're excited to have another great program for you tonight, and I'm going to start off. We'll have a quick little catch up on events going forward after the program. But I'm going to give it over to Stephen real quick, Stephen Slider. He's going to give us a quick update on repeaters before he has to skip out, and then we'll hand it over to Rob and our program. So Stephen, go ahead and take it away.
Thanks, John. So all of the analog repeaters seem to be doing fairly well at the moment. Not much to report. We are still having an issue with the 440 Stone Mountain D-Star repeater, which is in the process of being looked at. And had a great repeater committee meeting the other day, and looking forward to what all this coming year has for us. And that's it.
Okay. Yes, we did have the whole board attended that meeting, and it was a good, fruitful repeater meeting. I would like to invite anybody in the radio club that has an interest in repeaters. If you'd like to belong to that committee, by all means, let us know, and we'd be more than happy to find you a spot on that committee or any of the other committees that we have. So please do let me know, or let anybody on the board know if you have an interest in that particular committee or any of the others that we have. Thanks, Stephen, and please bear with us, especially on the D-Star. It is operable, but it does have issues. So that's the one on the mountain up there at Stone Mountain. So I'm going to go ahead and hand it over to our handsome, dashing, young Rob Osatin, KI4UTY, our programs chairman, to get us started for tonight.
See if I can unmute my audio here. Hopefully, they're working on the house across the street. Is that too noisy?
Nope.
That annoying? I can move inside.
No, you're fine.
Okay. Yeah, we have another great speaker tonight, and in our series of great speakers. One thing I want to say about that is, there are a lot of people around the country, who know things. Some, more than others, such as Carl, an expert on this. But the other thing they're doing, in addition to being an expert, is they're actually lending their expertise to us. They're sharing what they know with us and helping improve the hobby and helping educate us. So Carl, I appreciate that, and thanks for what you and the other ones do. It's funny, I was looking at how to pronounce your last name, and I looked at a bunch of YouTubes, and they would all start off with, our speaker tonight is Carl. Well, it's Carl. Yeah. So, yep. So I may either go with Luetzelschwab or just say it's Carl.
That was real good. We kind of Americanized it to Luetzelschwab. Luetzelschwab is okay also. Yeah.
We've had some tongue twister people on, including me, over the years. The brief summary I'll just give you, because I know Carl will give you his bio, but yeah, he was licensed in 1961, so he's been doing this for a while. He's a double E from Purdue, so he's a double E and a Boilermaker. He edited the National Contest Journal. He's into contesting from 2002 to 2007, and certainly if you're going to contest, knowing propagation and which bands are good, that gives you a secret weapon. And he was working on the propagation column after he left that until 2015. So, he's been very active. He is very active. He's retired from Motorola and Raytheon, and he designs solid state amplifiers. So he knows what he's talking about, and we're glad to have him I want to hear about weather. I want to hear about, we know about global warming. Maybe we'll hear about, solar system warming. But weather is always good to hear. And my last comment is propagation affects all of us in all bands. Most of it is for the HF, but even on VHF, when funny things happen to the sun, funny things happen on VHF and makes us happy. So we're trying to follow all that. So with that said, let me shut up and turn this over to Carl. Carl, it's all yours.
Okay, thank you, Rob. Let me get my screen shared here. It should come up and then I'll go to full screen. Okay, it's full screen for me. So just let me know when you see it as full screen. Oh, that's new. I never saw that before. Okay. Okay. Well,
Yeah, we have it.
Okay, I'm Carl, K9LA up in Fort Wayne, Indiana. And hello to all the Atlanta Radio Club members down there. We had a wonderful day today in the high 70s, sunny, light breeze. So Ida didn't affect us at all. I know it sure is affecting a lot of people down south though. Even I guess Pennsylvania had some flooding too. So let's see. Yeah, as Rob said, I got my novice in 61 and took K9LA back in, I think, 77 or so. I enjoy contesting, DXing, trying to understand propagation, vintage gear. I have 2 vintage stations. One is my novice station, and a National NC60 and a DX35. And another one is a good general station from back in the 60s, a Viking Ranger 2 and a Drake 2B. And occasionally I get on with those and play around. Have a lot of fun with those. My wife is Vicky, Alpha Echo 9 Yankee Lima. That really helps a lot. She turned 65 last December. She officially retired, but she's working part-time at a local elementary school. And she seems to enjoy it, so I'm sure she'll do that for a while. Part-time really helps too. Don't have to, don't have a whole long day every day. We like to travel, and hopefully one of these days we'll start going to clubs and flea market and hamfests again and conventions. It's kind of opening up, but we'll see what happens in the next couple months. So we're going to talk about the sun and the ionosphere. We'll talk about solar cycles. Then we'll talk about space weather. And we'll talk about cycle 25 because that's really important for the higher bands, 15, 12, and 10 meters, which don't offer many opportunities at the moment. Of course, the digital modes offer a little bit more opportunities. Still, it's going to get a whole lot better, probably in a year or two. So let me minimize my little picture of everybody there. So here's a picture of solar radiation. The sun puts out electromagnetic radiation at many wavelengths, from very, very short to very long. As you can see in the plot, the most intense radiation is at visible light wavelengths. That kind of makes sense. And, that's where our eyes are most sensitive. Now, and the energy of a photon is inversely proportional to its wavelength. So the shorter the wavelength, the higher the energy a photon has. And that's important because the photon needs a certain amount of energy to ionize an atmospheric constituent, which is either an atom or a molecule. So the important range of radiation for our amateur radio HF endeavors is very short wavelengths, and follow that green line all the way over to the left. And there's where the ionizing wavelengths are, way over on the left. It's shorter than ultraviolet. It's much shorter than visible light. And as you go along the horizontal axis, you'll see 10.7 centimeter solar flux. 10.7 centimeters solar flux couldn't ionize its way out of a paper bag. So it's a proxy for really what is most important. That's the extreme ultraviolet radiation. Here is a picture of a very simple picture of the layers or the regions of the ionosphere. A lot of times they're called layers. I think it's better to call them regions because layer kind of tells you that maybe there's a bunch of electrons at some altitude and then there's nothing until you get up to the next layer, but that's not true. The electron density is continuous. It just so happens that the F2 region has a peak and the E region has a peak. And there's stuff in between too, even between the E region and down in the D region. So it's better to call them regions. And of course, the regions are formed depending on the wavelength of the radiation from the sun and the number of neutral atmospheric constituents versus altitude. And the atmospheric constituents that are most important are atomic oxygen, molecular oxygen, molecular nitrogen, and nitric oxide. That's really what's important for our ionization issues. The F2 region is formed by extreme ultraviolet radiation. That's the true ionizing radiation of the F2 region. X-rays, a little bit shorter, result in the E region. Those X-rays have a little bit more energy than extreme ultraviolet, therefore they can get down lower into the atmosphere. And then the even shorter X-rays can get all the way down into the D region and form the D region. Of course, free electrons, which are electrons stripped from a neutral atom or molecule, are what is important for skywave propagation. And there, that picture just shows in the daytime, there's the D region, the E region, the F1 region, the F2 region, and at night, the F2 regions kind of combine. The E region goes away significantly, but there's still some ionization. And for all intents and purposes, the D region is gone at night, which is good. So general characteristics of the regions. Well, the F region is roughly between 150 and 400 kilometers. There are free electrons above 400 kilometers, but they don't play a role in our HF propagation. The F region is the highest in altitude, and because of that, it gives the longest hops. So if we're really going after DX type QSOs, we'd sure like to have them from the F region, whether it be the, mostly it's the F2 region, and that gives us the longest hops. The F region also has the highest electron densities, which are best for the higher bands, 15, 12, and 10 meters. The E region is roughly from 90 to 150 kilometers. When the E region is ionized enough, it can refract RF back to Earth, and the hops are shorter because it's lower in altitude. So again, we prefer an F2 region hop as opposed to an E region hop. And also, if the E region is intense enough, it can block signals from getting to the F region to give us those long hops. Then we get down to the D regions, roughly 60 to 90 kilometers. And basically, it's just a detriment to propagation due to absorption. In other words, it's loss. It reduces the signal strength. So it's doesn't serve a useful purpose for HF propagation. Solar cycles kind of determine which bands are open. The picture there shows the sun at solar maximum. There's lots of dark spots there, sunspots. There's a picture at solar minimum. There are few or no sunspots. Why are solar cycles important? For the higher bands, they're very important because the area around a sunspot emits extreme ultraviolet. And of course, extreme ultraviolet is what ionizes the F2 region. So when we have more sunspots, there's more extreme ultraviolet coming from the sun. That means there's more ionization, especially during the day in the F2 region. And that's the best propagation on the higher HF bands. And you can see that little figure on the right shows where in a solar cycle we have the best propagation on 15, 12, 10, and even 6 meters. It's at solar maximum. And just quick reference, a solar cycle is from A to B to C, from solar minimum to solar max, and then back down to solar minimum. On average, a solar cycle is 11 years from A to C. And on average, the rise time of a solar cycle is about 4 years. That's from A to B. And the decline is about 7 years. That's from B to C. Of course, those numbers vary. Some solar cycles are a little bit shorter, some are a little bit longer. In general, bigger solar cycles rise faster, so it may not take 4 years to get to maximum, or small cycles take a little bit longer to get to maximum. Why are solar cycles important on the low bands? Well, when we have less sunspots, we have less ionospheric absorption, especially at night, and there are less disturbances at solar minimum. So our best propagation on the low band is around solar minimum. That's indicated on that sketch on the right. So space weather, making sense of all those parameters that are out there on all those websites. But first, there's a caveat. You know, what we're trying to do is come up with some simple statements about HF propagation that are derived from very complicated atmospheric ionospheric processes. This kind of works a lot of the time, but where we really have a problem is predicting short-term events. One such short-term event is the day-to-day variability of the ionosphere. What's interesting is, like, for example, if the solar flux, the 10.7 centimeter solar flux is 80 today, and if it's 90 tomorrow, that doesn't necessarily mean the ionosphere is better. It could be worse. And that's because the variability of the ionosphere in the short term depends on 3 factors. Solar radiation, well, we kind of knew that. It depends on geomagnetic field activity. In other words, the K index, if it gets elevated, it could screw up the F2 region. And also, we're really doing a lot of research nowadays on events in the lower atmosphere that couple up to the ionosphere. So those events can also contribute to the variability of the ionosphere. And what all this means is we don't have daily propagation predictions. In other words, if you put in a daily solar flux or daily sunspot number into a prediction, it's not right, it's not correct. What you need to put in is a smoothed sunspot number or smoothed 10.7 centimeter solar flux, because that's how the model of the ionosphere was developed. Correlation between smoothed solar indices and monthly median ionospheric parameters. Now, median means 50% probability, so that tells us that our predictions are statistical in nature over a month's time frame. So that's something we just have to live with. Also, we have trouble predicting short-term enhancements, and I believe I have examples of those here coming up. Now, there's lots of websites with data, and I couldn't list them all, but here are some of the big ones that I'm familiar with. There's the N0NBH banner. It shows up at qrz.com and many other places. I have a picture of it on the next slide or the one after that. and you'll probably recognize it because you've probably seen it before. Dr. Tony Phillips does spaceweather.com. That's a good website. It has all kinds of space weather parameters. But he also has texts about related issues to space weather. So it's a good read. It's not just data. NOAA has the Space Weather Prediction Center website, and it is pretty much technically oriented towards lots of data, lots of explanations on everything too. Victor Echo 3 Echo November has solarham.net. You might be familiar with that and his website. And of course, Dr. Tamitha, Whiskey X-Ray 6 Space Weather Woman, does videos about the sun and its effect on propagation. So those are good to watch also. There are a lot of other general websites out there, and there's a heck of a lot more that are very more specific. For example, if you want to know what is the extreme ultraviolet doing day to day, well, there's websites for that and a whole bunch of other stuff. So depending on how deep you want to dig, there's something out there on the internet. So what parameters are important? Well, I've divided it up into two categories. The top bullet, those are the basic parameters that tell us if there's enough ionization to refract the signal back to Earth. In other words, is the MUF, the maximum usable frequency, high enough? That's the SFI, the 10.7 centimeter solar flux index. SN is the sunspot number. 304A is extreme ultraviolet radiation at 304 angstroms, and that's equivalent to 30.4 nanometers. That's pretty short. And there's also the MUF over the Boulder ionosonde. And what that does, it gives the MUF in megahertz at Boulder, if assuming Boulder is the midpoint of a 3,000 kilometer path. So it's a good indication of what the ionosphere is doing right now. And if you think about it, it's probably a decent parameter to tell you what the continental United States is doing. Of course, a little bit farther south than Boulder is going to have a little bit higher MUFs. A little bit north of Boulder is going to have a little bit lower MUFs, but it still gives you a good general idea. The second big bullet are the parameters that tell us if the Earth's magnetic field is disturbed. In other words, they tell us if the F2 region might be screwed up. The K index, you're probably aware of that. It's a 3-hour index on a linear scale. If there's a P appended to it, K sub P, it means it's a planetary index, which means it's an average of several observatories around the world to give a more worldwide view of the Earth's activity of the Earth's magnetic field. The A index is the average of the 8 3-hour K indices. So it's a daily index, whereas the K index is a 3-hour index. BZ, that's the strength and direction of the interplanetary magnetic field. In other words, the sun's magnetic field. Now, the Z component of that magnetic field is perpendicular to the ecliptic. What's the ecliptic? That's the plane in which all our planets go around the sun. So what it says is if it's perpendicular to the ecliptic, it's pretty much north and south, and that lines up with the Earth's magnetic field, which is basically north-south. And depending on the direction, it will tell us if the interplanetary magnetic field is coupling into the Earth's magnetic field. We'll get into that here in another slide or three. And SW is the solar wind speed. The higher the solar wind, the more likely the F2 region is going to be disturbed. And of course, the more likely there could be some auroral displays also. So that The top four are for telling us how strong the ionosphere is, or how strong it could be. And the bottom four tell us if the F2 region is screwed up. So here's that N0 NBH banner. It's very colorful. What I've put in gold boxes are the parameters I just talked about. And here's just a review of the range of those parameters. The solar flux index goes from about 65 at solar minimum all the way up to 245 at a big solar maximum. Sunspot number, of course, can go from 0 at solar minimum up to about 286 on a daily basis. 304A, that's the extreme ultraviolet radiation. It goes from about 90 at solar minimum to 400. Now there's also, it's really 90 times 10 to the 8th. So 90 is just a shorthand there. Don't have to carry that times the 10 to the 8th. The MUF US boulder is the daytime, and it can go from probably about 20 megahertz to 46 megahertz. That's in the afternoon on a winter or a fall or winter day. So let's look at what the those parameters were doing on August 6th at 1332 UTC, which would be 7:30 in the morning in Boulder. So the sun hasn't been up too long. You can see the SFI is 74. So now we know that the SFI can go from 65 to 245. So 74 tells us, well, we're pretty darn close, still pretty darn close to solar minimum. Sunspot number is 36. Again, 36 is a heck of a lot closer to 0 than 286. So that tells us we're still kind of near solar minimum. 304A agrees. It says 113. So it's closer to 90 than to 400. So we're at solar minimum. And then the MUF US boulder is, let's see where it's way at the bottom there. It's 15.6 megahertz. What that tells us is if Boulder's the midpoint of a 3,000 kilometer path, that 15.6 megahertz should be able to propagate over that path. That says 20 meters is certainly going to be open at 14 megahertz. Now it's lower than that 20 megahertz I have there in the range of the MUF. That's because that's early in the morning. It would get higher as we progress into the afternoon. Okay, is the F2 region disturbed parameters? Well, the K index goes from 0 to 9. And if we look at the N0 NBH banner, it's 1. So that tells us things are pretty quiet. The Earth's magnetic field is not disturbed. The A index goes from 0 to 400. It's at 2. That's way down there. So things are pretty quiet again. The BZ, roughly from plus 50 to minus 100. It's sitting at minus 1.8. So we'll talk about that in a little bit here. But it says that things are pretty quiet, and the solar wind goes from 300 to 2,000 kilometers per second. It's at 311. So it's, again, all four of those are confirming that the Earth's magnetic field is pretty quiet, and it's probably not disturbing the F2 region very much at all. Now, here's something to note. Here's a picture of solar flux, sunspot number, and EUV for cycle 23. Now, at solar minimum, you can see blue is the sunspot number. It can go to 0, right? Right. Red is the solar flux. It bottoms out around 65 to 70. And there, like I said, there's the extreme ultraviolet. It bottoms out about 90. and that's e to the 8th. And if you go through electron production loss calculations, that says that even at solar minimum, there's still enough extreme ultraviolet to keep 20 meters open at solar minimum during the day and early evening. Now, that also means frequencies lower than 14 megahertz. There's still sufficient number of electrons to refract the lower frequencies. And we're talking about the daytime. Nighttime is, things generally go down. And the MUF isn't high enough at night for 20 meters, at least around solar minimum. So what this tells us is that at solar minimum, the SFI equals 65, sunspot number equals 0, and the EUV 90 is a baseline. And values above those values can indicate when 15, 12, 10, and 6 meters may be open. And here's a chart that kind of showed that. There's the baseline in the top row. EUV is 90, sunspot number 0, and the solar flux is 65. That's solar minimum. And the monthly median MUF is about 20 megahertz. Now, what that says, that's a median value. There's a distribution about it. On 15 days of the month, 50% probability, on 15 days of the month, the MUF's going to be lower than 20 megahertz. And on another 15 days of the month, it's going to be higher than 20 megahertz. On a couple days of the month, it could be 23, 24 megahertz. Again, you can see that there's a statistical nature to our understanding of the ionosphere. Now, as those averages, or not, as those parameters increase, that tells us what's going on. Let's look at the fourth row, which is the average cycle, kind of like cycle 23. And when you see the that 304A up in 285 for a whole bunch of days, weeks, and months, that tells you that the monthly median MUF is up around 28 megahertz. That says that 10 meters is going to be open because it's considerably below 28 megahertz. And if we go to that big cycle 19, the biggest in recorded history, if you see the EUV at 400, sunspot number at 286, solar flux up around 245 for a long period of time, then the MUF could be 46 megahertz. And it also says that on a couple of days of the month, there's likely to be 6 meter propagation, because the probability is a little bit lower up at 50 megahertz, but still it's a couple of days of the month. How about Ka, Bz, and Sw? Okay, what we'd like in general is an undisturbed F2 region. And when we have that, the K is less than or equal to 3. A is a less than or equal to 15. And you can move between the K and the A index on that plot on the right. We'd like the Bz to be positive. A little negative is okay. When the Bz is positive, that means the interplanetary magnetic field is not coupling very well into the Earth's magnetic field. So it's not gonna, the sun's not going to disturb the ionosphere. And we'd like the solar wind speed to be not too much greater than 400. When it gets up to 1,000, 1,500, 2,000 kilometers per second, that indicates that there's probably a coronal mass ejection or a coronal hole. And that generally occurs on the declining phase of the solar cycle. So, although the SFI, SN, and 304A parameters may indicate there's enough ionization, we've got to look at the K and the A and the BZ and the SW, because they may say that the F2 region is screwed up. In other words, the ionization has been rearranged, generally lower. Now, if you don't want to go through all that stuff, Well, one thing you can do is go to dxmaps.com. What I did is looked at the world on 17 meters, April 13th from this year, from 1554 to 1644. And this tells you who is working, who else, okay? So you can see North America had a good opening to Europe. North America had a good opening into South America. Had a decent opening into the Pacific. Europe was working, of course, North America and South America and the Caribbean, and even looks like into Antarctica way down there. So this gives a pretty much a real-time picture of who is working who. So you really don't need to play around with all those parameters too much. And again, you can choose whatever band you want. You can just look at North America or Europe or wherever. There's similar info on PSK Reporter. WhisperNet has similar mapping. You may be familiar with the IARU, Northern Cal DX Foundation Reverse Beacon Network. If you transmit in a certain format, you can then go listen to or look at software-defined radios that are scattered throughout the world and see if you were heard there. So that'll give you a good idea what's going on. I'm sorry, the Reverse Beacon Network is just a bunch of SDR. IARU NCDXF beacons. That's the 2017, 15, 12, and 10 meter beacons. And they are, there are 18 of them worldwide. They each transmit for 10 seconds on a given band. So in 180 seconds or 3 minutes, you can tell what worldwide propagation looks like on a given band with those beacons. And there's software to help decode those and give you a great indication of what the real-time propagation is. Another way to look at real-time is the real-time ionosphere. Kilo Charlie 2 Golf downloads ionoson data. That's with the circles with the numbers. And then he adds contour lines. And what he shows are the MUFs, maximum usable frequencies for 3,000 kilometer hops. Now, I don't know if you can see it very well, but for example, here in Florida, the Eglin Air Force Base, ionoson at the time, 1815 UTC, had an MUF of 17 megahertz. So if that's the midpoint of a 3,000 kilometer path, then surely 20 meters would be okay. 17 meters at 18 megahertz might not be there. But this gives you a general idea of what worldwide propagation. Now, it would really be nice if you could add a great circle path from your QTH to a target onto this map. For example, to Europe, it's, you know, it's not a, like from Florida to Europe, it's not a straight line. It's kind of a humped line. So you'd have to understand that, well, over a portion, the MUFs are lower. So it would really be helpful for that to happen. I'm not sure if that's in the works or not, but that would add a lot to interpreting what's going on. Okay, so cycle 25. I don't know how many of your club members have been licensed for just several years. I don't know, 5, 6. But they may be asking what's so great about 15, 12, and 10. And most of the time, there's only noise and not many signals on those bands. Well, all I can say is wait a couple more years and you'll be amazed what those bands can do around solar maximum with low power and modest antennas. Cycle 24 was kind of small, but still around solar maximum. We had some pretty good propagation on 15, 12, 10 meters, and even some good propagation via the F2 region on 6 meters around solar max in the fall and winter months into Europe and Japan. So here's a look at all previous 24 solar cycles. It's pretty obvious that things are cyclical in nature. We've been through 3 periods of big cycles. For example, cycles 1, 2, 3, and 4 were big. 8, 9, 10, 11 were big. And 17 through 22 were kind of big also. Cycle 1 started in 1755. Cycle 19 is the biggest in recorded history. It kind of stands out here, 19. And I got in just as it was declining. But of course, I didn't know anything about sunspots anyway back then, so it didn't matter. Also, we've been through 2 periods of small cycles. Cycles 5, 6, and 7 are called the Dalton minimum. No relation to Dalton in the Roadhouse movie. We also had the Gleisberg minimum. Cycles 12 through 16 were kind of small. Not as small as the Dalton minimum, but they certainly were less than solar cycles before and afterwards. And we appear to be in a 3rd period of small cycles. So what that brings up is the $64,000 question. Will cycle 25 get us out of this 3rd period of small cycles, or will it keep us in it? Now, it's interesting to look at solar minimums in our lifetimes. If you can see there are 5 curves on the left of that plot. And what this plot tells you is how many months the smooth sunspot number was below 20. So for example, all of these were the minimum between cycles 18 and 19, 19, 20, 20, 21, 21, 22, and 22 and 23. And we went below a smooth sunspot number of 20. And then about after 2 years, we were ascending through a smooth sunspot number of 20. So our solar minimum periods were pretty small. But then along came the minimum between 23 and 24. That's the thick green line. And it lasted about almost 5 years for when the smooth sunspot number went below 20 until when it ascended through 20 again. So that one was quite discouraging because we didn't have much propagation on the higher bands for a heck of a long time, because we had gotten used to, only about 2 years of no propagation. And then this came along. So what's cycle 25 doing? Well, it looks like it's going to be even longer than the previous solar minimum. That's where we stand right now, and it sure looks like it's going to be longer. Now, historical data suggests that a long minimum period results in a small next cycle, and sure enough, we had a very long minimum between 23 and 24, and that gave a small cycle 24. So this kind of suggests that cycle 25 is going to be small, but the correlation in the correlation of a long minimum giving a small next cycle is not perfect. It's high, but it's not perfect. So there's room for interesting things to happen, and all we can do is wait and see what happens. So here's the here's a plot of the rise of cycle 25. Another thing that comes out of those 24 cycles is historical data says big cycles rise faster than small cycles. So the green is cycle 24, small cycle. Orange is cycle 23, which is an average cycle. Blue is cycle 21, which was a pretty darn big cycle. Not as big as 19, but it was up there. And in red is, to date, cycle 25. And it right now is rising similar to 24, the small cycle, and 21, the big cycle. So the next 6 to 12 months will likely tell us where cycle 25 is headed. Will it kind of more follow cycle 24, or will it hopefully more follow cycle 21? Or will it be in between, or even be lower than 24? All we can do is wait to see what happens. So if cycle 25 is similar to cycle 24, what can we expect in terms of the higher bands? On the left is cycle 24. The black data is the monthly mean 10.7 centimeter solar flux. Monthly mean is monthly average. In other words, you take the all the days of the month and average it. And you can see that's rather spiky. And so that's one reason why we further average the monthly means into a smooth value, and that's the purple. You can see that the plot is very smooth. It definitely tells us cycle 24 had 2 peaks. Why did it have 2 peaks? That's because the 2 solar hemispheres weren't working together. One dominated early on, and then it quieted down, and then the other solar hemisphere dominated while the previously big solar hemisphere kind of quieted down. Will that happen in 25? I don't even want to make a guess. I've not seen anybody make a guess about that either. There's the green lines are tell us what we expect what we need the solar flux to be, the smooth solar flux for 15 meters and 10 meters. It says we need a smooth solar flux of 90. In other words, that means 90 on many, many, many days, weeks, months, and we're not there yet for sure. So we still got a way to go before 15 and an even longer wait until 10 meters comes to life. Now, if cycle 25 is bigger than 24, of course, things will come back a little bit earlier. That's a pretty bleak picture, but what we need to do is watch for a big spike in the solar flux, the sunspot number, the EUV, or even a small spike in the K index. And that can reward us with an enhanced opening on the higher bands. And great examples are late 2020 and the 2018 California QSO party. So here's a picture for a year picture from August 31st, 2020 to August 31st, 2021. The black is the daily 10.7 meter solar flux. Red is the daily sunspot number. And this is around November 23rd of last year. You can see there was a pretty darn good spike. And what that did is it offered great worldwide propagation on 15 and 10 for CQ Worldwide DXCW contest. There was also enough, it certainly helped the CQ Worldwide phone contest in late October. And it also helped the ARRL 10 meter contest in early December. So watch for big spikes, okay? Unfortunately, after that big spike, things kind of settled back down to solar minimum conditions. You can see that daily solar flux, the black is around 70 or so. So it's solar minimum. We did have some minor peaks and we recently had one, but it helped a little bit, but nothing like back in late 2020. And I mentioned a spike in the K index in the October 2018 California QSO party. I did not hear any W6s on 10 meters on Saturday. The reason, well, here's a picture of the Boulder ionosphere, the MUF over Boulder for a 3,000 kilometer path. Boulder is pretty close to the midpoint between the Midwest here and W6. And it said the MUF on the first day of the contest was only around 20 megahertz. Well, that's not going to do anything for 10 meters. But on Sunday, the second day, the K index spiked up to about 5 for 3 consecutive periods. And look what happened to the MUF on Sunday. It got cleared a little bit more than 30 megahertz. That opened up 10 meters and I worked lots of W6s on Sunday. So watch for low and mid latitude enhancements when the K index spikes up a bit. You know, if it spikes up to 9 or something, well, that could be a problem. But if it's just a moderate spike up, take a look at the higher bands. So summary, we still have a way to go until 15, 12, and 10 are open on a daily basis. But it's a good time to start thinking about antennas for 15, 12, and 10. They are smaller at these frequencies. You know, a 15-meter inverted V at 20 feet would do wonders when cycle 25 is a lot better. It's only about 11 foot on a side, so it's not really big. And of course, 10-meter inverted V being smaller, you might even be able to put up a small 3-element 10-meter Yagi. And of course, at 6 meters, when we're at the peak of cycle 25 in the fall and the winter months, we might have some F2 propagation on 6. And don't forget sporadic E in the summertime on 6 meters. We had a really great sporadic E season this month or this year in the summer months. And sporadic E doesn't appear to be too correlated to a solar cycle. It's there every year. So always take advantage of it. And I can't stress enough, get on the digital modes. The digital modes have an advantage over sideband and CW, and they will give you more opportunities on the higher band. And I will say, because of FT8, this solar minimum period that we're just coming out of has been the most active on the higher bands, 15, 12, and 10, because of the FT8 mode. You can be working stuff when the CW and sideband guys don't hear a thing. And it's because the digital modes can detect signals farther down into the noise. And again, as a reminder, watch for short-term enhancement on the higher bands when there's a big spike in the solar flux and the sunspot number, or when the K-index spikes up to a moderate level. So Rob, that's all I had. Let me get out of that. And I can, whoops, already there. Yeah, okay. I'll keep this up if there's a question.
Carl, I popped a question into the chat box.
Yeah, let me look at it here. Okay, here, do you have any personal interest or opinion about historical? Yeah, well, the modern minimum was very few sunspots from, I think it was 1645 to 1715 or something like that, before we officially counted sunspots. But there's lots of good evidence that says, yes, there was a dearth of sunspots in that period, and the guy named Maunder kind of discovered it, I guess. So he got it named after him. Cycle 25, it doesn't look like we're going to be in a Maunder minimum again. Cycle 25 is generating sunspots. And so I don't think we have to worry about that. The Carrington event was back in 1859, I believe it was, something like that. It was a huge solar flare with a concurrent coronal mass ejection. And the auroral displays were seen in the southern states, so it was pretty big. Lots of interesting stuff happened on telegraph lines. If something like that happened nowadays, wow, we'd probably be in trouble. Satellites would have problems. Yeah, we'd really have a problem. The solar flare from back then exceeded our range of solar flares as we measure them today. So it was big. And of course, the coronal mass ejection that came out of it was awful big too. I'm not sure I've ever seen, I'm sure the K index, if we had it back then, would have went above 9. It would have maxed out and we wouldn't have known how big it was. There is a antipodal A index that has been going from the 1800s, and I had to take a look at that and see what that index did on the date of the Carrington event. Hopefully I answered the question, Scott.
Yeah, thanks, Carl.
How accurate were the pre-1950 data compared to today? Are we seeing more events because of new technology? Okay, I'm sure David, it's a question about sunspots. Correct?
Whatever, whatever was measured back then, obviously we're going to see more of it today. And, technology that didn't exist prior to even 20 years ago
Yep.
isn't as sensitive, and we can see more things. So are we seeing more things because they're occurring or because they couldn't see them earlier?
Well, there's a lot of stuff that's tied to the start of the space age where we can get satellites up there. We can see a lot better what's going on. A big issue is sunspots. How good is the data back in the 1750s when it started? Well, that was a great question that came up in the early 90s. And some people started wondering, how accurate is that data? So there were 4 solar workshops held, and all the data back till then was reviewed, and interestingly, more data was found. Basically they were sketches back then. And because of that, beginning in July, a couple of years ago, we transitioned to a new sunspot record. We believe that sunspots weren't counted enough back then, and that raised everything. That really screws up a lot of stuff. Our propagation prediction programs were correlated to the old sunspot record. Now we have a new sunspot record, so you got to be aware that that there can be a difference there. Of course, telescopes got better as the years progressed, and there are now good criteria on how to measure and count sunspots. So I think, we've learned a lot over the centuries. There's a lot of good data nowadays that, who knows, maybe in 100 years we'll look back and say, boy, we didn't know really what we were doing that well. But it's as good as it exists right now, and we seem to be using it pretty effectively.
Thank you.
Arnold asked, what effect did HARP have when it was active? Well, it had, of course, what HARP was trying to do is modify the ionosphere, specifically the E region, I believe. I don't think they were trying to impact the F2 region, and they're doing that just to study what happens in the ionosphere. So it was a very localized event, at least when they were just studying the ionosphere. So, and of course, if it modified the ionosphere a bit, that means things change, the MUF changed and all that kind of stuff. But like I say, it was, they radiated straight up, so it was pretty localized. Now I remember HARP, I think they did or they had 7 megahertz QSO party, I believe. And that was back, I don't know when that was, but and then they did some moon bounce type stuff for the hams too, because there's some hams working up there, and they were able to, get their fingers in the pot. So in general, HARP really didn't have a worldwide effect on the ionosphere. It was localized, and it was quite small too. So nothing else, Rob? Okay, from David, are there A, B, and C layers? Well, way back in most system resources may affect your audio quality. Yeah, right. Okay. um, Sir Edmund Appleton, Edward Appleton, who's a British subject, back in, let's see, it was about 1922, I believe it was, or 23, yeah, whatever. Measured the time of flight in transmitting a signal from station A to station B, and from that, he determined that there was a reflecting layer up at around 100 kilometers or so. So what he called it was the E layer for electric. So with that established, anything below the E layer would be D, and anything above would be F. So that's how they got named. Every once in a while, people talk about a C layer, which that could be to a very big solar flare or a gamma ray burst that we see increased ionization below the D region. As far as I'm aware, there's no A or B or anything talk like that, but there could be a C, very rare, but I guess it happens. And there's just the D, E, and F, and nothing above.
That begs the question of why did they start at E?
Well, it stood for electric.
Oh, okay.
Yeah, because they thought it was an electrically conducting layer up there that returned the signal to Earth. And so he just named it E. It was quite arbitrary, I guess. You could
Well,
have
I
named
mean, yeah, I mean D. What does that stand for? And
nothing. It's just alpha. Above and below the E region are just alphabetical. That's it. They don't stand for anything. You could think of the D region as detrimental, I suppose, and F for far distant contacts. That's it. No, that's not official, of course.
sounds good. Thanks.
Yeah, there you go. Any relationship between the demise of the sun and sunspot numbers? The demise of the sun. Val, could you explain that a little bit more? Oh, the sun burning out. Yeah, well, I always tell people if you've got some project that you need to get done in the next couple days, you don't have to worry about the sun burning out. Okay. We think the sun's going to start expanding and engulf the Earth, which is going to get pretty hot in maybe 5 billion years or something like that. I don't know what happens to sunspots when way into the future when the sun does that. I don't think I've ever seen anybody talk about that either. I'm sure we're not going to worry about sunspots. That's for sure. Okay, where does heaviside fit in? Okay. Remember Marconi heard the Poldhu station in December 1901, I believe it was. Well, there were two scientists. Let's see, Oliver Heaviside, he was a British, and the American guy, what was his name? Oh, shoot, Heaviside, and shoot, I forgot his name, but they independently postulated that there was some kind of conducting layer that allowed the Marconi to happen, the Marconi reception to happen. So those guys kind of suggested that there must be some kind of conducting layer, and that was in 1902. Remember, I said that Sir Edward Appleton came around in 1922 or 23, and he actually used measurements to say that, yeah, those guys are right. There is a conducting layer up there, and I'm going to name it the E layer for electric. So, Kennelly, Arthur Kennelly was the American. And it's interesting. There's some other people who kind of theorize that also, but Kennelly and Heaviside kind of were the two guys. And in fact, before some guy named Watt called it the ionosphere, it was usually called the Kennelly Heaviside layer. Kind of interesting. Just think if I would have invented it, it would have been the Luetzelschwab layer. How'd you like that? A mouthful. Okay. You mentioned mass solar ejections. Isn't it just a matter of time before there's another large one? Yeah, you're right. Yeah, just like there's going to be another big earthquake, and more than likely a big old meteor is going to hit us again. And yeah, that's right. Are we prepared? Probably not. So that'll be kind of interesting when that happens. Yeah, the sun is, in its most stable period here. It's about halfway through its life. It's about 5 billion years old. It's got another 5 to go. So things will probably get exciting in a billion years, I bet. But I don't think you and I have to worry about that too much.
Do they have any predictors for solar mass, mass ejections?
Well, how do you predict them? Well, you put up satellites around the sun and gather data, and we measure. We have a satellite. I can't remember the Discover. That's an acronym for a whole bunch of words. It's about 1 million miles from Earth on the path to the sun. So it gives us an early warning of the solar wind speed if it spikes up. And of course, we have satellites that can look at they block out the sun's disk, so we can look at the corona and see CMEs coming off and all that. I'm not sure, I'm not very up on, can we predict when a CME is going to happen? Coronal holes are a different story. And, we can see just by looking at the sun where there's a coronal hole, and that means there's a high speed solar wind coming at us. So that one's probably easier to predict because we can see it on the sun. We don't seem to see CMEs forming and then, breaking loose. The only tie we have is generally if there's a big solar flux, there might be a big CME. So, big solar flare, not a solar flux, a big solar flare, there might be a CME. But still, I'm not sure we understand enough about the sun to predict anything. And that's, of course, why we struggle so much to predict solar cycles. I'm aware of 56 predictions for cycle 25. Why are there so many? Because we really don't have the details on what goes on inside the sun to make a good prediction. So there are many different methods, and you come up with a wide range of predictions. Let's see, did you ever take a field trip to one? No, I've never done that. I should do that. Yeah, thank goodness we have fiber in the ground. Yeah. I hope it's well shielded. Yeah. Okay, does the effect of the moon's exosphere influence EME communications? I've never done EME moon bounce. I don't know. That's a better question for someone else, Val. The only thing I really know is that, you know, you like to work the moon when it's on you work moon mounts when the moon's on the horizon, because you get ground reflection gain for your antenna, as opposed to if the moon's high in the sky, and generally you're not going to get that ground reflection gain. So that's all I can say. I don't know anymore. You're welcome, Scott.
Hey, Carl, somebody asked,
I missed
you mentioned mass solar ejections. Did you see that question?
You mean about it's just a matter of time before there's
Yeah.
Yeah, you're right. And I responded that, yeah, it's only a matter of time before we have another big earthquake or a big volcano or a comet or an asteroid hit us. Yeah, there's a lot of things that could cause havoc on Earth. One new message. Okay, let me go see what that is.
Let me ask a question. What on VHF? How does VHF get affected? Does it, you know, do we get ducting out of it, or does that affect ducting, or what does that do for VHF?
Yeah, solar space weather doesn't affect VHF that much. Of course, you know, 6 meter F2 propagation, of course, is affected, but other than that, 2 meters is generally not affected. It's probably more affected by weather in the troposphere, in other words, tropospheric ducting, rather than any solar type issues. 6 meters, like I said, is can be affected by the sun. We talked about a spike in the K index. Notice that the when the MUF goes up to 10 meters, well, I think it's very possible that it could maybe every once in a while do something for 6 meters too. So there's always a possibility that 6 meters is affected by space weather. 2 meters and above, and not really. Let's see. Okay. Thank you, Val. So HARP might have changed enhanced 6 meter. I don't think it modified the ionosphere that much. I don't think it would have done anything to affect 6 meters. Not from what I've read. And it takes a heck of a lot of power to modify the ionosphere. And that's why they run lots of antennas and lots of kilowatts of power to get ERPs, effective radiated powers, into the megawatt range. So I seriously doubt if 6 meter propagation would have been affected by HARP. Oh, yeah, okay, thanks. Let's see, was that Wesley, I guess? That's how you pronounce it? Yeah, I don't know if it's a congrats or a condolences, but whatever.
I'll ask one more. So the muff.
Carl, it's your old buddy from Fort Wayne West.
Hi.
Somebody in there.
Yeah, somebody, and I didn't catch the audio too good.
That's because I don't have to. It's your old friend West from Fort Wayne, and I just congratulating you again on your dictatorship or directorship.
There we go. Yeah, dictatorship. There we go.
Whiskey
Well,
three.
I told everybody that, yeah, I told everybody, if they ask me how should we address you? And I said, well, just follow the lead of the Wizard of Oz movie. Just call me the great and powerful director. So that, yeah, well,
Very good, very good.
yeah, okay. I'm gonna have to do some more research. Yeah. ADE, how do you pronounce that? ADE or AID? Whatever, do some more research. I think you'll enjoy it. Is there a direct relationship between sunspot numbers and the divorce rate of hemaholics? Yeah, probably. Yep. Yep.
I'll ask a question. So the muff
Yep.
is the maximum usable frequency. That's every frequencies below that get bounced, and frequencies above that go shooting into space. That's essentially it.
Yeah, the MUF, of course, is specific to a specific path, point A to point B at a specific time in a specific month and during a specific phase of a solar cycle. So yes, and any frequency below the MUF is refracted back to Earth. Any frequency above goes through the ionosphere and it's lost into space. That's a general statement that applies most of the time. Interesting things can happen, like there might be some scatter that still makes it, even if the MUF isn't high enough. But generally, if you're below the MUF, you'll make the contact. If you're above the MUF, you won't.
And the delayer goes away at night. I think you said that, right? You were talking about the
Yep. Mhm.
and
Yep.
the which means you get better propagation. We probably have something separate. I know you've done all kinds of presentations on different aspects of this and other things, and just talking about which propagation, which bands are good at which times.
Mhm.
I know
Yeah.
there's a lot to that.
Yeah, one thing we have to remember is the amount of absorption is inversely proportional to the square of the frequency. So in other words, the higher in frequency, the less the absorption, the less loss your signal incurs. So that's probably the main reason why signals on 10 meters are, 10, 20 dB above S9, whereas signals on 160 are down at the noise. That's because absorption is inversely proportional to the square of the frequency. The higher in frequency, the less the absorption.
Yeah, the good news is when you get high enough, is the absorption is very low, but it goes out in space.
Yeah, you got to have, yeah, that's right. If there's enough like a good example, if there's enough ionization to refract 6 meters, the absorption is only about a dB. So it's extremely small. And of course that allows, and then that's why sporadic E can be so loud at times if it's a good sporadic E cloud. There's just not much absorption down in the D region.
I think Aid had a question about sporadic E, didn't you? Weren't you asking about sporadic E, Aid?
No,
No.
not me.
No, okay. I mean, not tonight, but okay.
Yeah, go take a look at an interesting website by K9LA. What he does is looks at tropospheric weather, wind shears and stuff like that, and creates what he calls the EPI, the E sub S prediction index. And he, it needs lots of validation, but it may indicate when sporadic E may occur, and it's done on a daily basis. All you have to do is Google G3 Yankee Lima Alpha, and that'll, you'll find it.
Anyone else out there? This is your chance for questions, everyone.
Thank you very much. It's a great presentation.
Oh, thank you. I enjoyed doing it. And oops, there we go. Was my audio broken up at all? Any?
No, you're fine.
Okay.
You're good. Yeah.
Okay.
I guess, I guess I'll say thank you. I guess everybody either understands it or they're all going off doing research.
Okay.
Carl, thank you very much for the presentation. It was everything I was hoping it would be.
Okay.
And
Thank you, guys. And like I said, Rob, I'll send you the a PDF of the presentation, and we can do whatever you want with it.
thank you, Carl. And I appreciate that.
Okay, I'm gonna, and I gotta turn the host over to, let's see, you want the host there?
I'll give it to John. Yeah,
Give it to John. I gotta find him first.
N3ACK.
Where is he? Where is he? Alvin Hard, must be at the bottom here somehow. No, where is he?
John, say something so you get. Oh,
Yeah, I see him.
okay.
Make host. What? N3? Yes.
Yeah, I was looking for how to reclaim it. I think
I have to do it. Yeah.
there's a button somewhere, but
Yeah. On your name on the right, there's a more. And then,
okay, I've got it back.
yeah, you've got it back. Yep.
All right,
I'll let you know,
thanks.
Carl, when the video's been posted.
Yep. Another great presentation. Thanks, Carl. It was
You're
really
welcome.
informative. I think we'll have plenty of people tuning back looking for links and things. So those will all be available on the ensuing recording and information slides that we'll have. So check back for that. But thanks again, Carl.
Well,
Thank you for being with us tonight from Indiana.
okay, I gotta get out of here and take care of the cat.
Yeah. We're going to draw for a $25 gift certificate for HRO here in Atlanta. Real quick, though, I'm just going to give you a quick, we have an activity coming up for the Atlanta Radio Club. This weekend, Bill, KB4KFT, and Skip, W4KEA, I believe. They're going to be up in Tennessee across the state line working the Tennessee QSO party. Information for that is on the website. You're more than welcome to join them if you want to make the trip. If nothing else, keep an ear out and try to make contact with them. The following weekend is the ARRL September VHF contest. The ARC is going to be doing an in the park event. We're going to be at Blackburn Park, which is on Ashford Dunwoody Road, just inside the perimeter from Perimeter Mall, actually, right inside the perimeter there. Join us for that. We're also going to have at that event, if you want, you can show up. We're going to have materials. You can make your own roll-up J-pole antenna that you can take home with you, obviously at no cost to you. So if you have an interest in that, show up for that. Gives you an opportunity to work the radios if you'd like, get rid of some of that mic fright, and take a antenna home with you. That'll be from 12 to 9 that day. And that information for that will be available on the Facebook site and the website going forward. The SCDXC Club is they're having an event this month with the 100 watts in a wire. You can find out more information about that at 100w.scdxc.org. It's your chance to make contacts and report back on your Scouts honor about what contacts you made and try to get a certificate and claim bragging rights. So check that out if you have an interest in. That's a month-long event, I believe. So check that out. And then, of course, tomorrow's lunch will be at Mellow Mushroom at 12:30 in Brookhaven, right there across from the Brookhaven Water Station. So do join us. We have a great time, have some great food, and we get to talk about radio, family, and a whole bunch of things. So join us September 18th in the morning. We're going to try to do a breakfast, location unknown at this point. So keep an ear out, keep checking the Facebook site and the web page, and we'll have more information on that. Let me see. I'm going to draw for this gift certificate. Got him in the hat. Let's see what we got here. We got Paul in for BFN. Are you still with us, Paul? Yep, Paul's still with us. So you are the winner of the $25 gift certificate to HRO for this month. So I'll send you an email with the certificate that you can use down at HRO. So congratulations, Paul, in for BFN. Aid, do you have any sort of a membership report and maybe a quick financial update?
Yeah, I think I can do that. The active members, we have 61, and financials, we have currently in the bank $16,542.97.
Okay. And once again, our membership is kind of on a 12-month basis. So when you join, your membership needs to be renewed the 12 months later. So we're not on like everybody renews at the same time. So if you've joined in the past and you're not sure if you're current or not, you can give Aid an email, hit Aid with an email. You can hit treasurer or secretary at atlantaradioclub.org and ask that question. And we're always willing to take your money. So if you're new and haven't been a member of the club, and it's a great thing to support the club and support our repeaters and other things that we're doing. So if you'd like to be a member, we'd love to have you on board. And we've got a lot of activities that are planned over the next 12 months. The board met recently, and we were going through the calendar of things to do. So we've got a year that's getting planned out going forward. So we're going to have a lot to do over the next 12 months. Got a Ham Fest coming up in June. Whatever rumors you may or may not have heard, they're probably not true. COVID killed us the last 2 years in particular. The facility just wasn't ready because of COVID. So as far as I know right now, unless some other variant, one of the 23,000 variants that might hit us between now and then, we should have a Ham Fest next June, the first Saturday, June 4th, I believe. So put that on the calendar if you haven't already. I think we've got Shelby Ham Fest coming up this weekend. If you haven't ever been to that, that's a great thing to go to. It's always on Labor Day. And of course, you got Stone Mountain coming up in November, the first weekend. I believe it's the first Saturday, 5th and 6th, something like that. So put those on your calendar. Thank you for being with us tonight. Do any of the board members are with us? I think we've only got one or two. Do y'all have any? Rob, what's up for next month's program? Do you have one yet?
No, it's a secret,
Okay.
even from me, but I should know definitely within a week. Well,
Okay. Well, you've set a track record that's going to be hard to keep up with, but we're looking forward to see what you come up with.
I can thank COVID for that, for having everybody available.
Anybody got any questions about anything club related, or any other questions you might have that you've been dying to ask somebody? All right. Well, like I said, thank you again for being with us. We've had some great programs the last 12 months. So if you missed one or don't know what we did, go to atlantaradioclub.org on the front page, and you can see a quick listing of our programs. And I believe they're linked so that you can go to the YouTube page. All of them have been recorded, so they're all there. And there's been some great ones. We have Bob Heil, Gordon West, all those had some big names and some great programs. So check those out. And of course, tonight's program should be up in the next couple of days. They do a pretty good job of getting it put together and viewable. So let's see, I don't see any other.
Go to the webpage, the website under meetings on the top menu. There's past meetings, and they're grouped into, I think, three year ranges. And so for the past year, certainly we've got all the YouTube links to the YouTubes on there.
Yep.
And the indexes that one of our our members kindly provides. The time index is telling you what happens, in each video at which time.
And thank you, Richard, KC4YMT. You're always welcome to check in. As with any club in the Atlanta area, they're all great clubs and all have wonderful presentations. So join us again next month. I'm sure Rob's going to put on another good one. So thank you all for being with us tonight. And like I said, do join us. Think about joining us on the 12th, the 11th, which is a Saturday, not this weekend, but next weekend. And let's play radio, and you can build an antenna and take it home with you. So thank you for being with us tonight. And everybody enjoy your week. And if you enjoy your Labor Day weekend, hope it's safe. Hope everybody's staying safe from COVID. And if you have any ham radio questions, feel free to hit us up, one of the board in the club, and we'll certainly find someone. If we can't answer the question, we are working on Elmer's list, and we'll find some folks who can answer your questions. So everybody have a great night and stay safe. And we look forward to seeing you join us either this weekend, next weekend, or next month's monthly meeting. Y'all have a wonderful evening.